My name is Peter Neumark, and I come from Prezi. In case you didn't know, Prezi is a presentation company who makes software that looks like this. And we went from serving 25 customers to 25 million in a little less than 4 years. I'd say that's not your typical growth trajectory. So many people seem to be wondering what Prezi got right. And as I was thinking about this, it seemed like many of the things that are part of the conventional wisdom are right. You do need to have a competent team, both engineering and business-wise. And this team needs to be growing constantly to keep up with the breakneck speed of where the product is going and where the users are going. By the way, we are a growing team. We are hiring if you're interested. You need to have market demand for your product. As obvious as that seems, if people don't want the stuff you're building, it's going to be really tough to acquire users. It just doesn't work out. And you need some sheer luck. And we've had our share. I really can't complain. I think the people who say you don't need luck say so because they've never built anything that requires luck. But all of these things, as important as they are, there's still an omission here. There's something left out that's really, really important. And it's very simple, actually. It's just a simple idea. I would say it's a principle. It's the fact that good enough is actually better than perfect. You should be fixing only what your problems force you to. That seems like something very, very simple, very basic, trivial even. But for a perfectionist, that's actually not simple advice to live by. And I know because when I came to Prezi, I was a bit of a perfectionist myself. One of the first features I started working on was the ability to have several backgrounds in your Prezi. Maybe you noticed that when I started presenting, it was as though we were stepping out of a room with the doors opening up. Now we are in a hallway, and as I zoom in even further, we enter the woods. And that's a bit how I felt. After several weeks of developing this code, I felt like I was lost in the deep, dark woods. My code grew, and as it grew, it became increasingly incoherent. And worst of all, this was all my fault, actually. The original feature, as invented by our product manager, was not very complicated. You just need 3 different images, select one depending on the zoom level. Not too tough, right? The reason it became so complex was that I wanted to future-proof this code. Perfectionism struck, and I thought, what if we could have several bitmaps in each layer? That would be so cool. In fact, I am absolutely certain that this is going to be a major feature request. So I'm just going to go ahead and do this right now, as a favor to everybody who comes after me. So it's easier to extend this stuff. Well, there certainly was a result of this forward-thinking attitude, but it wasn't that this feature ever got built. I've never talked to a single person who wanted several images in a layer, ever. It's never happened. But I have had a lot of people who came to me and said, dude, what are those extra indexes? What is your code doing? I have no idea what's going on here. Could you please help me out? Because this is way more complicated than it should be. And that's how I learned that good enough is a lot better than simple. Now, generally, I think Prezi engineers get this right. That's why we could grow at the pace at which we did grow. And one of the good examples where I think this worked out quite well is logging. So anytime you have a web application, the application itself, the front end, is going to be logging some usage data, some crash reports, error logs back to the web servers so it can be analyzed by product managers, developers, whatever. And all this is to improve the product further. Now, of course, Prezi also needs this, so the Prezi editor or Prezi player, whatever, the client, makes an HTTP request to Prezi.com and sends all this information along. It's a very simple solution, and it worked very well for us for a long time. But as more people start using Prezi, we needed more web servers. As we started having more web servers, there arose a need to aggregate all this data, all these logs, into a central location. How would you do this? You make a cron script, right? You make a cron entry, copies it once an hour, simple as that. And again, this worked quite well for us up until we decided that we want to have dashboards and graphs of what our infrastructure is doing, so we're not navigating in the dark. And when we built these graphs, we were appalled to see that all the graphs were on average 30 minutes late, because until that cron script ran, we didn't see any of the data. So we adopted the Scribe logging program from Facebook, which aggregates the data from all the web servers in real time. This gave us nice graphs, and we were very happy. But again, an issue arose. In the early days, Prezi.com was developing at breakneck speed, and we weren't always as responsible as we should be. So occasionally, very frequently actually, we'd have outages. And when we had an outage, we still wanted to receive logs. So we took this very simple logging program that recorded the post requests, put it in a separate service, on separate nodes, even in a different data center, and now we would have logs even when the main website was down. And again, we were satisfied for a while. But eventually, due to our success, more and more people started using Prezi, and this resulted in more and more logs. And when product manager Sue or developer Sally wanted to figure something out about the way the client was used, they would have to grep, awk, and sed for hours and later days. And that didn't work very well. So we introduced Hadoop. And up until about a little more than a week ago, this was the logging story for Prezi. And then two guys came along and said, what if we did structured logging? There's a lot of noise in our logs, a lot of stuff that's difficult to parse. What if we defined a schema for our log records? And this schema would say what kind of data you can log, what kind of fields are in there. It would be much easier and quicker to have data mining tasks then. So this is currently the last chapter, an ongoing effort in the Prezi logging story. A perfectionist, especially one who is attracted to strongly typed languages, and I know there's nobody here like that, but if there were, would probably start with making a schema for these log entries. That would be such a huge mistake. Not because the schema is bad per se, but imagine when we're at the 25 user mark. There's no iPad client. There's no support for any languages other than English. We're not available any other time zones except maybe 2. We don't have as many payment methods as we do now. What kind of schema would that be? It would almost certainly be something that we couldn't use today without modifications. And for years, we'd be struggling against a schema that is just not flexible enough. Now that we've learned a lot more about our customers, we can finally come up with a schema that will work for us for a good while. And another thing is, in the meantime, we created a logging solution that's very robust, and we got the information we needed to improve the client. If we would have wasted that time on coming with the perfect schema, we would have no logs. In summary, good enough is better than perfect. Now, if you have good logs that allow you to improve the product as you should, eventually, if all goes well and you have some luck, the users will come. And initially, you can get away with having a single database and a couple of web servers, and then a couple more web servers, up until a point. And then you realize that you can't scale this way forever. You have to break off chunks of the Prezi.com software, as we did with the logging part, and create a separate service with a separate database running on separate hosts, perhaps even in separate data centers. And that is exactly what we did. Some people call this the service-oriented architecture. You can call it that if you want. It worked well for us. But it did present some new problems. Things that were trivial before, like authentication and authorization, all of a sudden became a bit more complex. For example, the Prezi.com website still had access to all user data and all permissions. That is to say, who can view a Prezi, who can edit a Prezi. But the actual Prezi contents was stored in a separate service, thousands of kilometers away. So how can you tell that the person who's trying to access a Prezi has the proper rights? Well, we had several options. A, we could replicate user data. This would be a rather costly option. And if there was any lag in the replication due to network issues, it would bring about very strange and unexpected errors. So we ruled that one out. We could have database links between the two sites. But again, if there was a network error of some sort, or if we made direct API calls between services, we would be setting ourselves up for cascading failure. The failure of one service would automatically bring about this failure of all the others. So again, this was a no-go. We decided to adopt token-based authentication. Basically, the user goes to the Prezi.com website, is authenticated, and provided a token. Using this token, they can access a storage service. When this is taking place is in early 2012. And luckily, by then, other people already had this problem, and we had something to choose, something already existent. Oauth 1 and the budding Oauth 2.0. We looked at Oauth 1, and it had plenty of advantages. It's a well-defined standard. By this point, with several implementations that work. It definitely worked for Twitter, and they have more users than us, so it's probably not a bad idea. And it's secure even if you use HTTP. You don't need HTTPS. But there were some downsides as well. Because of the support for HTTP, the client is rather complex. There are a number of cryptographic hoops you have to jump through to use Oauth 1, which are easy to mess up when you implement them and very, very difficult to debug. Also, when you create this signed request, you have to have a client secret which cannot leak. Now, if you have two web servers communicating, and we can assume that these web servers are never compromised, which is a shaky assumption, but let's go along with it, then we can say, yeah, Oauth 1 is for me. But as soon as you have a desktop application, a mobile application, an application running as a Flash app or a JavaScript app, then some clever security engineer is going to come by, reverse engineer your secret key, and write some great paper about it, and then it's over. Plus, we use mostly HTTPS anyway, so all this complexity wasn't really a good trade-off for us. Okay, no Oauth 1.0. What about Oauth 2? No client secret. Okay, so far so good. Google and Facebook showed interest, and since then have adopted it. Okay, that's a pretty good endorsement. The client's much simpler. Okay, so far we like this. What about the bad side? Turns out Oauth 2 is not a standard. It's something people call a framework, which means there's a lot of implementations that are not interoperable. So we'd have to write our own, because there isn't a standard Oauth implementation. And we'd have to write our own damn well, because Oauth endpoint will be a single point of failure. Now, if the security folks thought that Oauth 2 was the best thing since sliced bread, we probably would have bitten the bullet and written our own. But the fact is, in the security community, Oauth 2 is frequently derided as being inherently insecure, notoriously difficult to get right, and just not worth it. So what do? Well, I'll tell you what we did. We came up with our own Prezi HMAC authentication scheme. If you're trying to access the contents of a Prezi, this Prezi in particular, you would make the request to the URL you see above, which, if you are authenticated and you have the proper rights, would respond with a JSON message. Now, you can look at this JSON message and see it has a URL, a header, and a method key. And those of you who've seen Oauth 1 before are probably saying, hey, this rings a bell. This looks like an Oauth 1 signed request. That's exactly what it is. So we took the Oauth 1 standard and said, what if we said the Prezi.com website was both the Oauth provider and also the client? So it signed its own request and then gave the editor all the information it needs to actually just assemble this request and launch it. This is definitely not the way you're supposed to use OAuth 1, by the way, if you're having doubts about that. But it has a lot of advantages for us. First of all, token creation is handled by the server, and the server signs the request. So the client is really, really simple. It's a single line, just about. We still got the HTTP benefit if we ever want to use it, because you do need HTTPS for acquiring the token. But when you're using it to talk to the storage service, you could even do it over HTTP. And finally, authorization was quite simple, because the Prezi.com website knew who had access to what resource. And because we have a REST API, the resource is already in the URL. So if you get a signed request to URL, you're qualified to view it. Simple as that. So the storage service doesn't actually have to do any credential checking. As long as the HMAC token checks out, all is well. Now granted, there are some disadvantages to this approach. For one, you can only do a single request per token, per HMAC Prezi token. Of course, that makes sense because in our case, the token is actually an HTTP request, a signed request. You can only make that signed request. Also, it's not suitable for a public API. There's no place for the user to say, I give my consent for a third party to access my data. This was the whole point of OAuth, you know? Why would we ever leave this out? That's the thing. It wasn't our problem. We weren't writing this for third parties. We were trying to get our website to talk to our storage service, and the carrier of the message had to be the client. And our scheme solves this very well, I think. Remember, good enough is better than perfect. And in this case, we fixed only what our problems forced us to. On September 25th, we improved 25 million lives in a minuscule way. Okay, really minuscule. We deployed a new version of one of Prezi's core services, hopefully causing fewer bugs, hopefully making some people's lives easier and more productive. But how did that happen? What were the steps necessary? How do we deploy at Prezi? As you can probably guess by this point, it was definitely an iterative process. So first, we had manual deployment. Two guys sat down next to each other. One of them took one of the web servers out of the load balancer. The other guy logged in, upgraded the application. They added the node back, rinse and repeat as long as you have nodes. As the number of web servers grew, this became very, very boring. So we came up with Fabric automation. Fabric is a very cool Python library, exactly for automating this sort of stuff. We didn't write it, but we do use it. We do like it. I do recommend it. And for a good while, this took care of our problems, as long as we weren't using Amazon's EC2. And then when we were, Fabric didn't work out so well. So one of our engineers came up with a very simple script which would go to S3, check a particular bucket for a new release of the software. If it found one, it downloaded it, unzipped it, and restarted the application with this new version. Mind you, this was 40 lines of bash. That's pretty impressive. And this worked quite well for a while, again, but we improved it in small ways, of course, only when we had a major problem that we needed to solve. So we added checksums, so we wouldn't have to download the new version to check if it was new or not. We made sure there was a random delay, so not every single application server went down at the same time to do the deploy. That would have been pretty bad. And again, we were quite content for a while. But then we thought of another problem. What if you want to test a version without deploying it everywhere? Well, that's called Canary Deployed. You take one node, you upgrade that one node, and you see what happens. You check the logs manually, and if everything checks out, boom, you distribute to all the other nodes, and you're done. And we used this for quite a while. We were quite happy with it. But the manual checking of the logs was very time-consuming, and it was error-prone. Humans mess up. That's just the way we are. So we decided to script this as well. But in order to make this work, we would have to place a small daemon on each node, which would check a central database as to what version they should run. When we did a Canary deploy, one of the nodes would receive the newer version. It would run that version. It could automatically check whether the service was healthy, and if so, all the other nodes would be upgraded one by one. We named the system placement. It's very flexible. It's very sexy. It's really an engineer's dream. Very soon, almost all of our services became placement services deployed in this fashion. And then this summer, the guy who wrote placement got a feature request to speed up deploy somehow. And he thought about it, and he said, you know, I don't really understand. Why do we have this sequential deploy? Okay, so the Canary node checks out, and then one by one we go to every server to upgrade. Why not do this in parallel? So he wrote the guy who did all the previous iterations of deploy script, actually sitting right there. And the guy said, you know, the reason we do it this way, because that's how we did it manually. Remember when I started talking about deployment like way at the very beginning of the circle? It wasn't a problem, so we didn't fix it. And I have to say, I am so glad we didn't, because I know of at least one major outage, which was only partial exactly because we did this sequential deploy. Now, I'm not saying we're going to hang on to this forever, but until it's a major problem, it's a bad idea to fix it. Good enough is better than perfect. So, in conclusion, what did we learn from Scaling Prezi? For one, I learned on my own personal mistake that minimizing WTFs per minute is more important than being future-proof. From the logging project, we learned that being reliable is more important than being intelligent and precise. Scaling means becoming decentralized. And sometimes, you just have to bend the standards in creative ways, as we did with the Prezi HMAC auth. Finally, it's all right if a rocket size is determined by the horse's ass. It's not such a big problem, as we learned with deployment. But all of these lessons are just specific cases when we realize that good enough is better than perfect. I want this to be my takeaway message. I hope you enjoyed my talk, and I will be giving another one tomorrow entitled What Comes After Rest. Please come visit me for that one too. Thank you very much, and now I would like to hear your questions. Ask me anything. Yes.
Okay, so this is not really a question. I think a lot of doing things perfectly, like improving too much, is driven by fear. Fear that you're like patching something and the good enough solution will not be good enough. Like the site is going to crash and you'll be like a fool in front of everybody else. So how do you decide if good enough is good enough or is like just good?
Thanks, that's actually a really good question. So to rephrase the question, I would say, how do you know when to stop, right? So you're working on something, you're improving it. When's the point when you say, okay, this is good enough, and I shall complete this now and no further? It's actually a really good question, and in order to do that, you kind of have to go back to where you start development, right? So there's this process of getting something from a problem to a solution where you start out by thinking about what the issue is. Okay, my servers are going down because of memory issues. People can't access the Prezis because one of the storage servers filled their disk, whatever the problem is. So you figure out what the issue is. Then you code up a solution, you write tests for it, you deploy it, you look at what the monitoring scripts show, you look at the dashboards, and if everything is okay, you're done, right? So there's this whole process. And if you do the process right, and you know exactly what problem you want to solve, then the first solution that solves that problem is the winner. So if you're confident that this is enough to fix it, you're done. If you're not confident this is enough to fix it, keep on working. Does that answer your question? I would warn against that. I don't think future-proofing is a good idea anymore. I used to, but not anymore. Yes? Kapcsolni ezt? Megcseréljük. So you'll get the speaker microphone, and I get to keep yours. Or just shout it out. Yeah, that's cool too. It's always hard to get into a perfect state. Gotcha. I think I understand the question. To rephrase it, what is the minimum that we can say is good enough? It's a bit similar to the last question, but you can say it's not good enough if it's not PEP 8 compliant. It's not good enough if there's no unit tests. It's not good enough if I haven't run it on a Canary node for a day and I've seen it work. So this is a great question. I think this is a little bit like when you have a definition of done for a team in Scrum or Kanban. And basically, it depends on what you're doing. So if you're working on your personal blog and you write code that causes an outage for a day, unless you're like Daring Fireball, who cares, right? You fix it, life goes on, whatever. But then if you're doing something like the Prezi.com website, yes, you should write unit tests for it. Yes, you should probably do integration tests for it. Yes, you need to be looking at logs if it's a major change. So it's up to the team, basically, I think, to have a standard for what's correct. And it's a very interesting dynamic of how the team arrives at this conclusion. This is a bit off on a tangent, but I think it's really important, so I want to say it. If you have an outage, and you don't have a post-mortem session where you talk about what caused the outage and how you're going to prevent it, then the outage was a total loss. Then you don't learn anything, then you're doing yourself a major disservice. If you have a small outage and you come up with a solution to it to prevent that in the future, and you prevent a much louder outage, then you won. You did a kick-ass job. Then you need to pat yourself on the shoulder. And I think that's how a team's sense of this is what's good enough comes in over time, crystallizes. Because through outage after outage, you think about what the problem is, you fix the most pressing problem and then nothing else, and eventually come with something that is very good. Not perfect, very good. We do have time for one more, I believe. Yes? I'm going to run over there so I can give you the mic.
You mentioned that you don't really test to have a solution which is future-proof, but do you have some kind of solutions also or test higher loads? So just to be sure that the solution, the infrastructure which is there, whether it can scale higher just by simulating users, or do you have such kind of a thing in place?
So just to rephrase the question was...
Can you get back on the stage?
Sure.
Thank you.
Yeah, welcome back to the stage. So the question was, okay, let's say the code works and gets its job done, but when you start having the first request and the second request, maybe it works, and then at the 25th million request, you run out of memory, you run out of file descriptors, the latency is too high, you have too many database connections. So as you scale something under load, it can behave very differently than it would when you have unit tests or when you're just trying it out on a couple of requests. Is that a good interpretation of your question? So do you need load balancing to determine if it's good enough? Again, I would say it depends, right? So we do have tools which we can use to DDoS ourselves, as funny as that sounds, and sometimes we do. That's when the network guys are really scratching their heads and drinking coffee after coffee. But you don't always need it. I mean, if you have a bug in a piece of software that for some reason sends back invalid JSON, and then you go find that equals sign right before you close that list and you remove it and everything works, of course that's not going to cause issues. So it depends. You have to be intelligent about these things, but generally speaking, yes. You can never be sure, you can never be 100% sure that it's good enough until it's good enough under load. I saw a hand up there a second ago. Okay. Thank you very much for your attention. Thank you for your questions. And you can always reach me on Twitter or email or in person, and I'd be more than happy to talk about this or anything else. Thank you.